everyone. My name is Kelsey Nowell. I am a data scientist interested in solving uniquely human problems. I'm also interested in engaging locally, and that's why I chose to predict future water consumption for the city of Austin. I have a background in management consulting and software implementations and a bachelor's from Harvard University. Here you can see images of Lake Travis in May 2015 and November 2012. You can see the difference between drought and higher rains. These are examples of the extremes of climate change, which pose unique challenges to the day-to-day operations and the long-term resilience of water utilities. Water utilities are not something that we should take for granted. It's very difficult to hit a moving target, and by planning for that, where that target is going to be, we can be more successful and more prepared for the future. The data sets I used for this project include the issued construction permits, as well as residential water consumption and commercial water consumption. For this project, I chose to focus on the residential water consumption. While the commercial is important, those projects are often planned years in advance, hand in hand with the city. The residential, knowing where people will land when they move to Austin and where we can expect that water demand to increase, allows us to understand the geospatialization of where that demand will increase and allows city planners to be prepared for the future. The issued construction permits allows us to have a way to see into where that building is happening and the likeliness of where that water consumption increase will take place. Here you can see my data pipeline. I gathered my data sets from the City of Austin's open data portal, and I used standard machine learning libraries in Python to process that data and to use regression models for predicting that data. I then created plots and visualizations using Tableau, Matplotlib, and Seaborn. However, no project would be complete without a unique set of challenges. For this project, I had a series of challenges, including messy data, particularly in that construction permit data. It's updated daily, and there's almost 2 million rows of data in there. So we've got missing values, we've got inconsistency of values across columns, and also a fair amount of features with 66 columns using trial and error and also common sense to figure out which of those columns would help my model, my regression model for predicting the total gallons of water consumed by zip code by month for the city of Austin was challenging, as well combining those data sets. As you can see, there's a large difference in the number of rows of data, and for my target variable of predicting the total gallons of water consumed per zip code, I had to aggregate the building permit data in order to combine those data sets and then feed that into my machine learning regression model. As well, with Austin is sort of a unique city in the grand scheme of things. It is really on top of water initiatives, both in awareness and changing those rate structures in the last few years to actually decrease the per capita consumption despite having gained a couple 100,000 in new residents. So finding that signal in the noise was very fun. To give you a sense of the data, here's one plot for one zip code among 45 for the city of Austin. This is the domain area. You can see the green dots are residential, so that's going to be your standard homes. The purple is multifamily, so that's going to be your apartment complexes type housing. And then the red is irrigation for the residential, and the blue is irrigation for the multifamily. You can see clear trends in the seasonality, so increases in the total gallons consumed for that zip code for that month during a summer month. As well, you can see that there are trends upward, but there is a lot of noise in that data. I solved this problem using a 3-step process. I cleaned the data, and I also was able to aggregate that data. I created a lag, so using the building permit data, I used a couple months to understand that people might not be moving into those newly completed projects right away, especially if it's a large apartment complex. Filling those residencies may take a couple months, and so I added a lag in the building permit data before I combined that with the residential data. With my goal of predicting the total gallons of water consumed for that zip code for that future month, I was able to use a number of regression algorithms, including linear, lasso, and ultimately random forest was the main algorithm I settled on for my model. And then I created some visualizations to help communicate that insight. With the goal of predicting future water consumption for the city of Austin, and the goal of better city planning and targeted efficiency efforts, I created a model. For those who aren't familiar with R squared, this is a measure of that my model explains in terms of the total variance of the data. This is on a scale, so 100% would be a perfect model. Mine's 99.3%. For those unfamiliar, you can see the predicted values from my model here on the Y and the actual values of those total gallons on the X. You can see that my plot is right along that Y equals X line. The fact that these points are hugging that line shows that my predicted values from my model are very close to my actual values, which shows that my model is quite good. Here is an interactive, it's actually a GIF of an interactive data visualization I created in Tableau. You can hover over the zip codes and see the total gallons consumed. And it goes from 2012 through 2016, and you can see certain areas like the domain area, for example, change from a light peach color to a much darker red, which aligns with a lot of the development that is happening in that area. Again, showing the thesis of my project, which is that we can use building permit data to better predict future water consumption for the city of Austin. Many thanks to the amazing people at Galvanize and the city of Austin for the data. If you'd like to learn more, check out my GitHub page, or if you'd like to contact me, do so via LinkedIn or by email. Thank you.